Quick revision video on atom economy. So we'll start with the essentials. Atom economy is the measure of the efficiency of a reaction in terms of the atoms involved. It doesn't deal with the efficiency of the reaction as a whole process. So in other words, it doesn't consider the reaction not going to completion, the reaction maybe being reversible, and possibly loss of material through the process. Atom economy considers the desired product and any byproduct of a reaction. And atom economy can be calculated from the balanced equation. So the formula we use for that looks like this. So atom economy is the molecular mass of your desired product over the sum of the molecular masses of all of the products times 100. Or you could do it where you look at the sum of the molecular masses of all the reactants instead. Either way, you still get the same answer. I'm going to use the first version of the equation in all of the calculations that we're going to look at now. So here's the first one. It's about making butan 1-ol from the reaction with 1-bromobutane and sodium hydroxide. So we've got to calculate the atom economy for the production of the alcohol. So if you want to pause the video, have a go, and then play on when you're ready. So obviously the desired product is the butan 1-ol. So basically all we're going to do is work out as a percentage of all of the atoms in the products, what percentage have gone into the product, the desired product. So there's that formula again. So it is 74 is the mass of this, the MR of this. The MR of everything is 176.9, and then just multiply that by 100. And so we get an atom economy of 41.8% for that reaction. So here's another one. So if you want to pause the video and then play when you're ready. So in this one, the desired product is hydrogen. I've chosen this one because it's balanced with a 2. So that's important when it comes to calculation. So there's the formula again. This time we've got to factor in that 2. So the MR of the desired product is 2 moles of hydrogen, so it would be 4, not just 2. And again, if you think about it as a proportion of all of the atoms that have gone into the desired product, you can see the importance of the 2, and so the answer is 8.3%. So we've got to come up with a reason why the atom economy is so low for this reaction, and that's down to the relative MRs of the desired product and the byproduct, the carbon dioxide. So carbon dioxide has a relatively high molecular mass compared to those 2 moles of hydrogen, and obviously that's going to affect the percentage and make it low. We'll just quickly look at atom economy and reaction type, and then we'll do some more calculations. So addition reactions have 100% atom economy, and the reactions I've chosen are all going to make the same desired product of ethanol. So in this one we've got an addition reaction where basically all of the atoms have gone to make the product. So there's no waste product, there's no byproduct. Literally made what we want. So they would always have 100% atom economy. Substitution reactions would always be less than 100% atom economy, and so the reaction to make ethanol via a substitution reaction looks like this. And finally, elimination reactions, they also have less than 100% atom economy, and to make ethanol via an elimination reaction you could do this one here from glucose. So for the second and third one, again, if you want to pause the video, work out the atom economy and then play on when you're ready. So the second reaction has an atom economy of 44%, and the third one 51.1%. Remember, we needed to double the MR of ethanol for that one. The final slide will look at atom economy, the environment and sustainability. So basically low atom economies are bad for the environment and bad for sustainability. So we'll just use a very simple scenario to explain this. So suppose the atom economy for a reaction was 50%. So we could argue that half of the energy used by the process is effectively being wasted. So you could argue then that the fossil fuel, or half of the fossil fuel, is effectively being wasted, and it's produced unwanted greenhouse emissions. Often byproducts have to be treated before disposal. You can't just get rid of them without making them safer for the environment. So that's going to require more energy. So you're using up more fossil fuels, and you're probably going to have to treat them with other chemicals. So you're using resources purely to dispose of your waste product. So a very, very simple solution could be to recycle or find a use for the waste product of products.